This time I got a JVC HRS7600. It's got the dreaded dynamic drum servo failure, the broken gears. It's going into shutdown mode. It needs the emulator installed, and we have one here to do. So we're going to put the emulator in and get this unit back up and running. It was sent to me, well, kind of in pieces. It's been into, everything was disconnected, but we got it going in the end. This time I have a JVC HR7600 that someone's been in because the power cord has been removed. Apparently this one here has a distorted picture, and of course it got shipped in with a couple of other units with packing peanuts. Again, I tell people, do not ship shit with packing peanuts, or I'll send you the vet bill when my cat gets sick. I already lost one cat a couple years ago due to packing peanuts. Huge vet bill because they initially thought it was a tumor, but once they got in, they found out that the cat had ingested a packing peanut and it got stuck in its intestines, and unfortunately they couldn't save the cat. That was after $6,000 in vet bills due to packing peanuts. So send me stuff with packing peanuts, I might charge you more for the cleanup. I just hate them because you open the box and you get packing peanuts. You cannot open a box without getting packing peanuts on the floor. And all it takes is a little piece to get tracked in, or the cat comes out here for some reason and decides it's going to eat one, and we got a problem. They should be banned. So this unit here, obviously somebody's been in here because things are disconnected. I guess I'll reconnect everything and see what it does, see if it gets a picture. I want to power this unit up and just see what the symptom is. And the guy that owns this, he sent me some DD emulator boards to disable the dynamic drum, because of course the dynamic drum on these things has a tendency to break on all these machines. The gears break and just junk. So what some people have come up with is an emulator board that uses a Raspberry Pi to generate pulses to fool the microprocessor into thinking that the drum is actually moving when it's not. And that's about the only way to keep these things running, because once the gears break, and they will, they become a doorstop basically. Okay, let's power this thing up and see if we get smoke. Okay, well, mechanism just reset. That is good. You use these units when you power them on. They normally go through the process of shifting the dynamic drum slightly. Oh, it's been unplugged too, you see? The head drum's been unplugged at the back here. Everything's been unplugged on here. I just want to see what the symptoms are before I do anything. So watch the little gears down here when I hit the power button. That's what they do. That's what the emulator does. It provides pulses to make the system think that it's rocking the drum back and forth, because these are the gears that break. So they haven't broken on this one yet, I don't think, because they're still moving and the head drum still got some play. But we need to, I want to test the machine. I want to see what else is wrong with it before I get into anything else on here. Of course the front loader is out of alignment. Why would I even expect that to be correct? Couldn't put a tape in. Alright, let's just see what this thing does. It doesn't do anything because I've got that stupid initial setup screen on the TV, so I don't have a picture. How do I get rid of that without the remote? Try powering it off and on. Well, this unit appears to be playing fine. See what I mean? Playing an SP tape fine. I'll try an EP tape and see how it looks, but Yeah, this one's playing fine. TVC off. TVC on. Don't really notice any difference in the picture. So playing back an SP tape is fine. Let's try an EP tape and a Super VHS tape at that. This is a Super VHS tape recorded in SP. It also is playing perfect. We'll try an EP tape next. We'll put the dynamic drum emulator in this one while I've got it apart. But everything else seems to be looking good on it. This is a recording from EP. Got the tracking track up here. This is off a laser disc. Looking good so far. A little bit jumpy there. Okay, I just experienced that the dynamic drum gears on this one are bad. When I moved it into another speed, I could actually hear the tick, 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 tick. One of the gears is cracked. That's probably why it shuts down when it's put in search. Why is it flashing constant video calibration? You can probably hear it. I don't know if you can hear because the air conditioner is running, but I can certainly hear it ticking away. And of course the alignment is a little bit out on it now. Wonderful. I probably have to reshoot that part and not show you what I showed before because I had the screen showing, and of course it'll pull a copyright, but the alignment is off on here now, and it's because the dynamic drum is out of position. I should be able to compensate that. By tweaking the guides a bit. Keep this in mind, I'm doing this without looking at a scope. I'm going to put it on the scope when I'm done, and I got it absolutely perfect. Okay, it's back. We're going to pull the drum and install the emulator board on this machine. And I'm going to do it without shutting it off and unplug the power, because as we saw before, it kicks when it's first powered up. But it appears to be in the correct position right now. So we'll just undo the drum and remove it. Remove the screws that hold the drum in place. Gee, those screws were loose, like somebody had been in there too, but at least that one was. These ones are tight. Or tighter. Oh, well, this one. Yeah, that one's better. So we can now remove the drum. It just unplugs. This is the problem child. These gears. You can already see we can see the cracks on here already. And the emulator board just plugs in down here in place of this little circuit board, which is going to come out. The little emulator board just plugs in, and this is based on a Raspberry Pi Pico. The program is inside here. We just line up the pins and plug it into this connector. that is the replacement, and then we're going to remove the circuit board from the other piece so that it doesn't try to well, first of all we need the clearance for one, but we got to remove the little circuit board on the bottom of the head drum over here, and that's to give us clearance, and then this will sandwich the board in place. If you look down closely here, you'll see this one's already cracked. You can see the crack right there. There's a crack. Right? That plastic is cracked. This plastic is cracked here. These gears themselves are probably ready to fall apart. So we want to make sure that they don't turn. They're in the correct state now. These other gears also can break. I remember I used to change these gearboxes on these units. They're just a piece of junk. But we're going to unsolder the motor over here and remove this board, and then reinstall the drum. I was actually lucky to get this one back, because when I went into fast forward, it went into full shutdown. And I couldn't get the machine to turn back on. I actually had to nudge the gears with my finger a bit to get them to move because it was stuck. And that got it back into the home position, and the tape is playing. So that was good. This one was right on the verge of a complete disaster. Pop those little catches out there and lift out this board. And we can examine the rest of the electronics on here. Okay, so what we've got on here, if we look down here, there are two optical sensors. And those optical sensors read the gears turning. There's two of them right down here if we look. There's one right here. We'll get a close up. So as it turns, there's two gears on here that I've got. Throw some light in there so you guys can see it better. You can see this gear here. There's the optical sensor, and then there's this one over here when the motor spins. This one counts the pulses. And get out of alignment and you're dead in the water. The gears break. You should see that one's already... Yeah, that one's ready to fall apart. Anyway, I think we got this one in time. We put this drum back in, and this unit should function. But here's the little sensor board. And it's just got these little sensors on. Little optical sensors. Has an LED on one side and a phototransistor on the other, and it just counts the pulses. So that's gone. Let's get the drum reinstalled. Also, if you're going to ask me where the emulator boards come from, I don't know, because they were supplied with the machines for service. So the fellow that owns these, he sourced the emulator boards. I don't know where he got them from. eBay maybe? But anyway, that's that. This should just tuck in here. If there's enough clearance, there should be. It should just drop back in. Unfortunately, this one's not going to fit because there's a capacitor in here that's standing up, and it's preventing the board from completely seating, and then I can't put the drum in because there's not enough clearance. So I either have to remove this capacitor and mount that below, or make up an extension cable in order to mount this outside of the unit itself from underneath the chassis. Might be just as easy to make up a cable, because there are headers that are included in the bag, so I can plug a header in here with a cable and just extend it. I think that's what I'll have to do, is do that on this one. I've made up my header cable here, 6 wires, and no, I don't have any flat wire, so don't even suggest it. Who do I look like, DigiKey? No, I'm not going to order it in to do this job. I don't have any scrap stuff to take ribbon cables from, or headers. because I don't generally keep the scrap. If I'm disposing of something, I just toss it. I don't keep. I probably should, but I don't. So I just made one up using 6 wires. We're gonna hook the other end up over to the emulator board over here and fish it underneath and plug it in, and that should get this one to run. So let me just connect it up to the other end here, pin for pin. On the emulator board, the header that normally would plug in here, it's got other connections up here that are pin identical. So if I start with pin number 1 here, I can just go all the way across from the top here and just plug them into this and solder them down. So I've got the wires now all connected straight through. I've marked pin number 1. I guess that's what this one here is. I've marked this one with a black mark as well as over here, so we know that that's the first one. That way when I fish this under the chassis, I'll get the alignment correct. This is the one that's going to go to the back. So let's plug it in, and we'll tape it down so that it doesn't get in the way of any of the guides or anything that might be moving around. So we'll bring it in under here and turn it over. We'll just push this little board over to the side, and we'll plug the header in right here. There, now the drum will sit back in place. Now if everything's operating as it should, when I power this up, it should operate and play properly. I'll reconnect the video head. There we go. It's seated now. Plug the drum motor back in. Now we can test, see if it's working. All right, power the unit up. Hasn't turned off, that's a good sign. Playing perfectly. Excellent. Now the dynamic drum only was operational in the higher speeds, like for search. So if I go to slow-mo or pause, the picture should be good. I don't know how to work this thing. There we go, that's pause. Slow motion. If I go to 1.5 times should be good. 2 times should be okay with just one little line in the picture. But if I go to the higher speed search, you're going to have lines in the picture because this is where the dynamic drum actually did its job. And this is what the emulator is doing now, is it's giving it the pulses to the microprocessor to tell it that the drum has actually moved, but the drum hasn't moved. If I go back to play, the picture will be perfect. And there we go. Looking good. This is actually time lapse that was done with video camera. So this was shot at the normal speed and then it was sped up. Those lines you see in the picture, that's just from shooting the plasma screen. Just the resolution of the camera is higher than, you can see the dots on the screen here. But yeah, that's looking good. Reverse search. You get the lines in the picture as normal because the drum's not moving. Looking good. I'll put my EP tape in now to verify it plays. Then we'll put the alignment tape up, look at it on the scope and make sure that everything's good. I think everything's perfect on here. Even the EP tape is playing perfect. Alright, there's the alignment playing in EP tape. This is the AFM output. That's where we look at the AFM. That's the one that's harder to track than the video head. So we always look at AFM. I'll put the color bars tape up and we'll see how that one looks. And you should see some lights blinking on this little emulator board too when it tries to do the different modes. I'll show that in a minute here, but here is AFM coming off of a tape. Where's my... That's looking pretty darn good. It's hard to see with the rolling shutter, but that's looking pretty good. If I were to tweak the guides, I mean that looks pretty much perfect. But just so I show you guys, I'll move the one of the guides here, maybe the exit guide. I think that's the easier one to get to. See? Right here, exit guide, absolutely perfect. Go to the entrance side over here. This is the one on the left side. And you see that? There's the entrance side. So the alignment on this machine is absolutely perfect.
And I did that by eyeball without a scope.
Here's a little emulator board. Watch what happens when I try to change modes. It's now sending a signal that it's at the higher speed. 5 times, it'll go to 7 times, you see? It's sending the signal out. And it's sending the reply. So in other words, it's sending the motor signal and it's sending the pulse signal to tell the system control that it's actually done what it said it's doing. Back to normal play. That's actually 1.5 times. It does actually try to move it, but of course it doesn't really affect the picture much until you get over 2 times. It's going to slower and slower speeds. Now we're going reverse. And we'll go back to play. That's the emulator board installed. For those wondering where the scope was clipped, it's marked, right? It's marked. That's the RF out for the audio head. That was the RF out for the video head on there as well, and control track pulse over here, and ground. So those are the 2 test points. Trigger off the control track. So that's pretty much it on this one. I'm just going to throw some tape over the top of this just to hold this down. Not that it's going to go anywhere. I've got the wires are taped down to the board to keep them out of the way, and I'm just going to tape the unit down itself so that it doesn't move, as we don't need to see it. And I'll leave the little lights visible. I'll throw a piece of tape over top of it just to hold it in place so it doesn't get banged around when it gets shipped back. Let's say we got this one just in time because Those gears, they were shot on this unit, and it actually shut down on me when I tried to play it initially. So we saved this one. We saved a lot of work getting that head back in alignment, the drum back in alignment position. So this one we had to extend the wires because they just weren't long enough. They should include that in the kit. They should include the header when you're buying these things. I don't know what those cost, but they can't be cheap. So I don't have any machines myself that need this particular mod done to it, as I avoided the dynamic drum machines like the plague because I knew what a big piece of junk that they were, and they were all time bombs ready to go off. Now this is an option to get these machines, save them from ultimate failure, and get them working again if they have gone bad.
Let the world hear our sound. Big thanks to you all for being around. Big thanks to you.
Just gonna put this movie in and let this movie play.